we see constant news of grand new space missions. These proposed missions often take years of planning, preparation, and execution. Space missions attract a lot of attention, but it's not uncommon for them to be altered or canceled. That being said, we have seen remarkable achievements made by NASA and private companies, like SpaceX and Blue Origin. But there is one country and space agency changing the game. This is India. It's a country with over 1.3 billion people, the second largest population in the world. And it's expected to overtake China in the coming decades. But its population isn't the only thing on the rise. India's first satellite, Aryabhata, was launched by the Soviet Union in April 1975, and for 33 years its space industry remained rather stagnant. Until recently, all space missions are directed by the government's Indian Space Research Organization, whose vision is to harness space technology for national development, while pursuing space science research and planetary exploration. In October 2008, their lunar orbiter, Chandrayaan-1, was launched and discovered water ice. In November 2013, their Mars orbiter mission was carried out, which successfully entered Mars orbit in September 2014. At a cost of just $20 million, they sent the orbiter with 5 scientific instruments. And unlike all 3 agencies before them, they did it on their first attempt. February 2017 saw ISRO launch 104 satellites on a single rocket, setting a world record. They did this on their Polar Satellite Launch Vehicle, which carried 1,300 kilograms of payload. It successfully deployed all 104 satellites from 7 different countries, sending them on the right paths while it traveled at 27,000 kilometers per hour. To put it into perspective, ISRO's budget in 2018 was set at only $1.7 billion, compared to NASA's $20.7 billion. India now has plans to launch a second mission to the Moon, followed by a manned spaceflight in the coming years. Chandrayaan-2 is India's second lunar exploration mission after Chandrayaan-1, scheduled to be launched in April 2019, although this mission has been rescheduled. As of February 2018, the mission has an allocated cost of approximately $125 million. The mission is planned to fly on a geosynchronous satellite launch vehicle Mark III. It's a 3-stage medium-lift launch vehicle, measuring around 44 meters in height, and a cost per launch of between $46 to $62 million in 2017. As a comparison, SpaceX's Falcon Heavy has 2 stages, measures around 70 meters, and has a cost per launch of $90 million. Once in space, the orbiter will orbit the Moon at an altitude of 100 kilometers. The mission lander is called Vikram, named after Vikram Sarabhai, who is widely regarded as the father of the Indian space program. It will detach from the orbiter and descend to a lower lunar orbit, before attempting to land on the lunar surface. The lander's propulsion system consists of 8 thrusters for altitude control, and 5 liquid main engines. If the lander is safely on the surface, a 6-wheeled rover will be deployed. Operated on solar power, the rover will perform on-site chemical analysis and send the data to the orbiter above, which will relay it back to Earth. A total of 10 electric motors will be used for traction and steering, accompanied by kinetic traction control, which will enable the rover to navigate the rough lunar terrain. The landing site is a high plain between 2 craters, Manzanus and Simpelius. If successful, Chandrayaan-2 will be the first mission to land a rover near the lunar South Pole. This mission will use and test various new technologies and conduct new experiments. ISRO stated, the payload will collect scientific information on lunar topography and mineralogy, elemental abundance, lunar exosphere, and signatures of hydroxyl and water ice, which will provide more data after the information collected 50 years ago by the human Apollo missions. ISRO plans to use the experience for more challenging missions in the future. such as touching down on an asteroid or Mars or sending a spacecraft to Venus. The first crewed flight is planned with a spacecraft called Gaganyaan for December 2021. ISRO have successfully demonstrated this by having a prototype re-enter the Earth's atmosphere, withstanding the thermal heat caused by friction, but there is still more tests to be done. ISRO will also be conducting test flights for a new and improved rocket, the SSLV, or Small Satellite Launch Vehicle, set for summer this year. As the name implies, the SSLV will launch smaller satellites that weigh between 500 to 700 kilograms. At just 34 meters tall, the rocket has 4 stages, with a payload capacity of 500 kilograms. What will make these vehicles so special is their low cost, being 1/10 the cost of a PSLV. SSLV does not require a mission control center to launch the satellite. It can be launched from some personal computer anywhere, assembled for launch within 72 hours. India's economic approach to spaceflight and its constant innovations are likely to bring many benefits to the future of space travel and will remain a key competitor in the space industry for many years to come. A special thanks to our patrons, Shara Ogilvy and Jimmy Alexander, for supporting this video. Thanks again for watching.